So this is lesson 1.17, and let's take a look at this. Segment CD is the perpendicular bisector of segment AB, which means that CD right here is splitting AB perfectly in half, and of course this is a right angle. So we need to find each transformation. So a transformation that takes A to B. So how could we get A to land on B? Well, we could spin it around M, right? We could spin it around M. That would be 180 degrees, right? 180 degree spin, whether we go clockwise or whether we go counterclockwise. All right, so then it says a transformation that takes B to A. Well, since we already did a rotation, why don't we do a reflection? We could do a reflection across CD, and that would land on A. If B reflected across CD, our line of reflection, then B would land on A. Cool. All right, a transformation that takes C to D. Well, we know that CD splits AB perfectly in half, but we don't know that AB splits CD perfectly in half. It looks like CM is a longer line segment than MD. So if I were going to try to reflect this or rotate it, and I used M as, if I rotate it around M, C is going to be way down here because it's longer than it is from M to D. And if I reflect it across AB, it's also going to get up past where D is. So the only thing I can do is slide or translate C down to D. All right. And then a transformation that takes D to C would also be another translation, right? D up to C. There's only one way to do that, at least given the information that we have. Okay, cool. Next. All right, sort the cards into categories of your choosing. Be prepared to explain the meaning of your categories. Okay, so as I look at this, okay, fine, I'm going to refresh that. That's fine. The idea here is that I can move these things around. I'm going to zoom out just a little bit so that we can see, so we have a little bit of room to move things around. All right, so let's see here. This one looks like you just slide it, right? This is just a translation, right? So that not much happens there. I don't see anything else that's just a translation. Okay, well, I see some stuff that's not rigid, right? This is not a rigid transformation because it changes the size. So that, we'll put that over here. This is also obviously not a rigid transformation because it gets all stretched or squished or whatever. This is a rotation with some maybe translation, a slide and a turn. And this looks like the same thing. This is also a slide and a turn. And this is looks like a reflection. So these, well, you could just say that all these up here are all rigid transformations, and these down here are not rigid transformations, right? That would be one way to do it. Let's see here. Next one says, then sort the cards into categories in a different way. Okay, great. Well, well, again, this one is not a, whoops, I need to zoom out first, and then we can move them. Okay, this one has a rotation. This one has a rotation. This one has a reflection. This one is not rigid. This one is not rigid. Oh, you know what we could do is we could go, these are quadrilaterals, right? 1, 2, 3, 4, 1, 2, 3, 4. These are triangles. We could group them that way. And then these, they're just weird. Like they're long, you know, they have more sides than 3 or 4. You know, that's one way we could do that. So we could group them that way. Anyway, it says for each card with a rigid transformation, so that would be this one, and this one, and this one, and this one, not that one. Write a sequence of rotations, translations, and reflections to get from the original figure to the image. Be precise. Okay. So for ABC, right, it's just a translation up from A to A prime, and then it looks like a rotation 90 degrees around, clockwise around A. My cat is climbing all over the place. I don't know if you can hear that in the background. This one looks like a translation from W to W, and then a rotation clockwise around W. And that's probably about 135 degrees. Why do I say that? Because this looks like a 45-degree angle off of vertical. So to get V to land on V, that would be a 90 plus a 45. So that'd be about 135 degrees. This one just looks like a translation straight up, just like from G to G, and everything will line up. This one looks like it is a translation from R to R prime, and then a rotation counterclockwise, looks like about 90 degrees, and that will put S on S prime. And then we would reflect it across, this RS, which would be vertical R prime, S prime, and it would land perfectly on that one. Okay. Next. So for each card with a rigid transformation, okay, we did that. Diego observes that although it was often easier to use a sequence of reflections, rotations, and translations to describe the rigid transformations in the cards, each of them could be done with just a single reflection, rotation, or translation. All right, so if I look back at this, let's look back at this. Can I do each one of these up here in a single move? Yes, we could. Right? You could figure out where the perpendicular bisector would be for C and C prime, which would be somewhere around in here maybe. And then something like that, right? If there was a line segment from C to C prime, then you would take another one that would be from A to A prime, which would maybe be something like this, I think. From A to A prime, maybe. Hard to tell. And then from B to B prime, and that would be something like maybe like this-ish, I think. Right? And it looks like they all they're pretty close. Right? It looks like right around in here somewhere there would be some magical point that we could use as a center of rotation and get all of these things to rotate around and land in the right spot. At least I think so. It's hard to tell. So anyway, great. And you would do the same thing here, right? You draw a perpendicular bisector for W prime, X to X prime, Y to Y prime. There's a perpendicular bisector for each one of these, and all of them should end up crossing at the same point, and we use that as the center of rotation. All right. Well, since this is a one step anyway, that's already done. And then here again with the reflection, you could find the perpendicular bisector of R prime, S prime, T prime, U prime, and that perpendicular bisector would be the line of reflection for that. And you could do that all in one step. Okay, so Diego observes that although it was often easier to use a sequence, you could do it in one step. However, Priya draws her own card, which looks like this, and she says, whoops, it can't be done as a single reflection, rotation, or translation. It just can't be done. So, well, let's take a look. Can we, if we do this as could we try to do this? How do we do this with one step? Well, I can get B and C to line up in one step, but then there's another reflection involved because the A, right? If I put B on B prime and C on C prime, if I did that, managed to get that to work, the A would still be up here and I would still have to reflect it down to get to that A prime. So it wouldn't work. Okay. All right. Now here, this is actually the exact one of these, and we talked about how we would do this. So I guess in terms of why this doesn't work is that there's a reflection involved and a rotation involved and a translation involved, and you can't combine all three of those into one step. Okay. So here we go. So how could a reflection work here without knowing where that line of reflection is? How could he tell? Well, the thing is that if we just draw, let's just draw some lines here from S to S prime, and from T to T prime, and from R to R prime, and from U to U prime. What do we notice about all these lines? Well, they appear to be going the same direction, also known as they're parallel, right? And we know that when something gets reflected across a line of reflection, the points travel at a 90-degree angle to the line segment, to the line of reflection, which is also a perpendicular bisector for that segment. So if I set up a perpendicular bisector and I choose S and S prime, we'll notice that, well, look at that. It's going to be the same line if I choose R and R prime. It'll be the same line if I choose T and T prime, and U and U prime. So that just goes to show you that it's going to work. We can reflect this across a line. So here we go. We're going to reflect this object across this line, and bam, nailed it. See? Worked. All right. And we just talked about how we would find exactly where it was. You just find the perpendicular bisector between any of the two corresponding points. The corresponding points would be, S's corresponding point would be S prime, T's corresponding point would be T prime, etc., right? You just find the perpendicular bisector, and that ends up being the line of reflection. All right, so that's the lesson part.